Hello, my name is Mike Smoyer, President at Digital Government Institute. Thank you for joining us. We're here today to discuss how the IRS unlocked data from legacy applications. The ongoing pandemic has highlighted the need for government agencies to quickly and accurately share data outside their organization. Our objective is to explore how the IRS was able to liberate vast amounts of data locked up in legacy applications, bring it for use across the agency and beyond. Before we get started, you have an opportunity to submit questions by typing your question in the chat question pane on the control panel. Send your questions at any time during this presentation. We will address during the Q&A session or after the conference. This session is being recorded and a follow-up email will be sent with a link to the session. It's now my pleasure to introduce our speakers. With us today is Terry Miholland, former CIO, CTO of the IRS, and Darren Graham, Chief Architect, Software AG Government Solutions. Thank you both for joining us. We look forward to hearing what you have to say. Terry?
Thank you. Appreciate the introduction, Mike. And I look forward to discussing with all of you just how the IRS unlocked data from legacy apps. All enterprises have this issue with legacy apps. In fact, one definition is as soon as you develop a system and implement it, immediately it's a legacy. The question is, why isn't data readily available in these applications since we use the most modern ways to develop software? And the problem, however, goes way back in time, which is individual programmers and teams, as they built applications to be used in production, didn't necessarily implement them by an architecture. They didn't construct a data model. The IRS is no different than any of those enterprises. In fact, the tax processing set of systems, roughly around 36 of them that handle your tax returns, all were built around sequential files. And while the tax code as implemented is incredibly robust, nonetheless, getting access to the data within those is a bit of a chore, because the programmers at the time did not have available to them database technology or other tools. And in fact, when databases came along, the system of legacy apps got worse in a sense because everyone chose different databases or chose different ways to implement data. For example, Social Security number, highly popular within the IRS. It's 3 numbers with a dash, 2 numbers with a dash, and 4 numbers. The question is that treated as an alphanumeric or is it a number with or without the dashes? Some people use periods to separate the numbers and such. So if you don't define that kind of term up front, getting access to a Social Security number in different systems becomes a real chore. And in fact, in the solution for the IRS ended up being with the 700 plus applications that exist in the IRS, that people had to write, and still do, extracts, which I'm sure all of you suffer with, is writing extracts to pull data from the systems in which that data is buried. Well, the solution for the IRS, unlocking it, was starting with the premise we needed a data model. That is a single standard way to recognize what the key data elements are and to get them implemented. So this is both the definition, I can use Social Security, for example, saying what is then the logical representation of that, what is the term we use, and then the physical representation. And then an architecture is needed, which says we will follow the use of that data model in all new applications. Then writing as again for these legacy apps, is for the systems that didn't have a database, stand up a database where you start populating it with the using the data model as the reference, and then from that point on, all new applications can utilize that data in a standard way. All right, that's a chore. In fact, at the IRS, it took us roughly 6 months to build a data model. And then the problem of converting all those sequential files I mentioned became paramount, and we needed a lot of help from the people involved with the legacy systems. They are in fact key. Do they see the need for this technology? And I believe what we did was convince them that it was in their best interest to use the most modern technology available. And it took roughly 2 years, almost 3, to convert all those VSAM files over to a database. But the real question then is, if you're a CFO or investor, what value is new? All you've done is rewrite the code, so to speak, to gain access to data that should have been done that way in the beginning. Well, what we chose to do was, in addition to building the data model and the database, was to use tools, in this case, Software AG's web methods, was a very nice way to write an application program interface in using standards within architecture. This allowed us to gain access to the data, unlock it in all those 700 systems that we determined, and to start managing that as a real resource for the enterprise. So it's a people issue, is getting people on board with respect to the technical skills they need, use of the most modern set of technologies like web methods. And at the time, we didn't realize we were building an integration hub. We began it as, oh, we have to have access to certain data to handle taxes in a new way, such as for electronic filing and customer-facing applications on a website and such, that we began to realize, hey, there's a lot of integration issues here that would be incredibly handy to have a tool like web methods and its APIs. Now, having done that, as such, and seen the success that we could have with it, it opened the doors to what I call a set of consequences. Now you have a set of APIs that have to be managed. And you have to think about that from an architecture point of view. And there again, portfolio management concepts enter the fray, and it's one of the wide open opportunities for IT shops to think about their integration techniques, APIs, web methods, but how they then manage that collection of APIs. Again, Software AG has a great tool for this. In fact, from my point of view, it was a holy grail solution, Alphabet, wonderful portfolio management concept. I'm not going to really talk about that today. Perhaps Darren will find it, put it into his conversation. But from my point of view, is that we found a method, web methods, that really allow the IRS to unlock data while we go about the issue of redeveloping, rewriting code into a data model-based database. With that, as an introduction, let me turn this over to my partner, Darren, at Software AG.
Thanks, Darren. Really appreciate that. I think there's a lot of valuable lessons that you can learn with large-scale systems like you're talking about, Terry, where you have hundreds and hundreds of systems, and you have to kind of evolve them into a state where they need to be, interchanging and exchanging data where they weren't maybe originally designed to do that. And especially when things have, different data models, it can become a real challenge. So I'm going to spend a little bit more time talking in detail about what Terry has been talking about, and specifically kind of hone in on this concept of a government integration hub. And so, as you heard, my name's Darren Graham, and I'm a Chief Solution Architect for Software AG Government Solutions. So before I get into some details here, I'll tell you a little bit more about myself. So I came to Software AG with the acquisition of web methods, and for almost 17 years, I've been really amazed at how forward-looking the web methods products were at the very beginning. It's not only set them up to be very relevant even today, but over the years, the company has invested billions of dollars improving and hardening the technology so that it's a industrial strength enterprise system suitable for large organizations, much like the IRS. So if I rewind back a little bit further, way further actually, back before web methods. So I grew up in the 80s as a teenager. And when I was 11, I made it clear to my parents that my only Christmas wish was to get an Atari for Christmas. So I dreamed of playing Missile Command and Space Invaders and Asteroids and drinking copious amounts of Tab and eating Pop Rocks. But under the tree was a surprise that would spark the interest of what will become pretty much my entire adult career. It was a Commodore VIC-20. It was a home computer. And I have to admit, I was
a little bit disappointed when I unwrapped this under the tree. I'm like, a keyboard? Where's the joystick? You know, I'm saving files on a cassette tape. It was very odd, but it was only a couple minutes after I opened, my shiny new home computer that I was actually authoring, programs using a basic programming language. And so it was a really rapid start, and for me, it really translated into not only a hobby throughout, my childhood, but also, it influenced my career. So here's a shot of my setup from then. My VIC-20 workstation. Obviously, that's not me sitting at the keyboard. That's one of those infamous or famous Cabbage Patch dolls that were popular at the time, which, if I recall, was my sister Heather's lone wish for that particular Christmas. So some wishes do come true. But you can see my workstation's set up, and it was complete with a really cool tractor-fed dot matrix printer. You can see kind of in the upper right-hand corner. And right in front of it is an expansion pack that my father, Don, built. And here are some of the specifications of that setup. And thanks to that expansion pack, my early programming efforts had access to almost 40 kilobytes of RAM. Yeah, 40 whole kilobytes. So just for some perspective, a completely empty Word document is around 11 kilobytes. So kind of gives you an idea for the scale at which I was working. But if you kind of fast forward now and look at this in contrast to a typical home computer you can buy today, like a Raspberry Pi, you can see that in so many ways, the new home computers that we have are quite literally millions of times better than what I had at the time. And of course, at the fraction of the cost. And given these huge leaps in the advancement of technology, many people are still surprised, and you may come across this too, Terry, is that folks are surprised to learn that there's still a significant number of government agencies and other organizations that leverage legacy technologies like mainframes, for example. Now, of course, the hardware that we see here has been modernized over time, but as you said, Terry, the code and the logic that were built decades ago are still powering some of the largest organizations even today. So when you combine this with the fact that agencies have been fielding newer systems with modern technology year over year, we can appreciate the need and the challenges that we see in integrating all of those systems together simultaneously. While some organizations are improving the way they integrate systems within their own agency, the recent pandemic has clearly uncovered the need to improve how we share data with those even outside the organization. And I think this is because though we're a digitally connected community, we're not typically a data sharing one. We've seen the impact of this during the pandemic as early on leaders struggled to collect data to facilitate accurate decision making. And unfortunately, this is not an isolated problem for any single state or region or country. The key here is that we all rely on data to understand our current situation and help us try to influence the future. And this is equally true for researchers who are pursuing a vaccine, or regional governors searching for ways to optimize their supply chains, or agencies tracking the use of payroll loans or other relief funds. So enabling technologies like cloud computing, big data storage, and analytics can help facilitate this actionable decision making. But these create an even greater demand on integration because, like Terry said, data is often locked up in silos and they're not often sharing the same data model. So this is why organizations like the IRS decided to deploy integration, or sometimes called middleware technology. And this is the foundation for the Government Integration Hub. And this is because a fundamental underlying challenge to many of these scenarios is the ability to access the data where it is managed. So Terry mentioned there's a lot of effort, extracting data out of systems in order to be able to gain value of that. And while a lot of that data can become available, and access to it in a timely fashion and at the right level of detail sometimes becomes a challenge. So because these systems are different and there's no common data structure and they're owned and potentially controlled by various organizations, the Government Integration Hub provides the ability to extend and reach into any system of record, access the data needed, and move it where it can be fused and analyzed to support better decision making. or it can help ingest large amounts of data and help validate and transform it and route it appropriately for processing. So if you think about processing tax returns in April, typically in April, maybe not this year, there's a large amount of data that needs to be validated, ingested, and routed to appropriate systems within the agency. So this data also could be moving between state and local level to the federal level, or vice versa. It could be data that's sent to and from banks, for example, who are processing payroll protection loans and distributing funds. Having this integration layer that abstracts these disparate sources provides a real bonus to organizations because it makes their evolution toward modernization much, much easier. So let's go a little bit deeper into the details of the Government Integration Hub by exploring what is a very simple, but I think a pretty representative use case. And we'll see a demonstration of this in just a few minutes. So this is a simple example of how we address common data synchronization problems across systems within an agency. We'll be, in this case, synchronizing employee information from PeopleSoft, which is the system of record for employees, and SAP, which is the system of record for financial data. And in this example, the employee has incurred an expense and they need to be reimbursed. But in order to have a check that gets generated from SAP, the employee must first have a cost center record created in SAP. But in the past, this has become an issue because it's a manual step, and it's resulted in significant delays and lots of time and energy spent by the accounting team researching why particular employees were not getting reimbursed timely because they didn't have a cost center created before the check was needed to be generated. So what you're going to see next is how Web Methods will take care of fetching data from PeopleSoft, and before updating SAP, Web Methods will validate that data and identify the region using a business rule. And then finally, Web Methods will create the call center record in SAP automatically. And when I talk about a business rule, in this case, we're using a simple example of saying, based on the state, what is the region in which that employee resides? Because that has some influence over the logic that is needed over in SAP. And because we want to use a business rule, it allows non-technical people to be able to manipulate that if those requirements change over time. Okay, so let's switch gears and let's take a look at the demo. Let's see here. Okay. So our first step is we're going to log into the PeopleSoft server, which is the source system. We'll use a link that we've saved before, and this will take us to the employee search screen. So we'll use this search screen to look for a valid employee ID. And this is what we're going to use for the demo to identify who we're going to move, what data we're going to move. So we'll enter KU and click search, and we'll use the first one, which is Douglas Lewis. So let's take a look at the details for Douglas Lewis. Clicking on the link brings us to the employee details screen, and we can navigate to the contact information tab, which is going to contain the data that we need to synchronize with SAP. Note the address is Malta Avenue in New Jersey. So next, we'll switch over to a synchronization request screen, and we only use this for the purposes of the demo to trigger the synchronization event. Normally, this trigger happens in a variety of ways, either automatically from an event in the application, based on a schedule or a batch, or triggered via an API. And then finally, we'll switch over to the SAP UI. And here we can see when we look up the cost center based off of this employee ID that we just searched, we can see that the data is created and all the data is populated here for Mr. Lewis's, including the region, which is East, based on the state of New Jersey. Again, that region was calculated by that very simple Web Methods business rule. Okay, so we just saw how Web Methods integrated data between PeopleSoft and SAP by taking an overall approach of abstracting both systems. And the Web Methods integration platform provides a very simple wizard-driven adapter concept that makes creating these APIs to access these systems and the data within them very fast and very easy. But integrating between two enterprise systems is often not a straightforward process. So what we've done is assembled these APIs to form a logic flow in web methods using a drag and drop authoring tool. And then once this process kicks off, it not only can sense and alert for failures during these transactions, but it can also provide the auditing and visibility into any of these transactions, especially for non-technical team members. And in order to avoid writing code, like you may find with other solutions, the Web Methods platform also creates and provides these editable business rules. So non-technical teams can not only author, but update these as appropriately as regulations or as requirements change. So in the previous example, we saw data synchronizing between enterprise systems like SAP and PeopleSoft. However, Web Methods provides unparalleled connectivity using hundreds of pre-built adapters, and Software AG certifies and fully supports every single one of them. So our customers don't have to rely on partners or the community to ensure that their solutions are able to deliver on the requirements. So whether you're looking to integrate ERPs in your own agency or establish your own integration hub, or even exchange data with other hubs, we recognize that there are several key attributes that you should consider in a solution. First, you need to be able to handle large amounts of data in any internal or external data sources. And real-time response times to inquiries need to be within sub-second, even during volume spikes. You need to have full auditability and traceability with the ability to validate data all the way back to its trusted source. It needs to be highly secure, of course, ensuring the data is protected during processing and then only available to trusted requesters. It has to have a comprehensive connectivity to any disparate data sources, whether they're on premises, whether they're cloud-based, mainframes or other legacy applications, cloud services, or data lake platforms. It needs to maintain data independence with the ability to accept, process, and generate any kind of data in any format. When Terry was talking about the standardization of the data model, this is where a visual drag and drop of being able to map between different data sources really is very helpful. And finally, it needs to be built on a robust technology platform that's proven in banking and high-tech supply chain, Fortune 500 financial systems, even in the Department of Defense. Software AG Government Solutions also provides reference architectures for implementations of government integration hubs, for example. And what we see in this drawing, it depicts an example for Microsoft Azure. However, we're agnostic about which cloud providers our customers would prefer to use, and we work really hard to be able to run on any of them. And this gives our customers the ultimate flexibility should they choose to leverage cloud resources in the first place. Of course, we also have customers who still prefer to deploy on premises for a variety of reasons. The key here is that these architectures are documented as templates, which are sometimes called infrastructure as code. And these can be used to automate the creation of all of these assets in this architecture drawing that you see. So basically, with the push of a button and a sip of your coffee, all of these components will be created for you in your cloud system of reference automatically. So in summary, data integration is still a major challenge throughout government agencies. And I think this is especially true for agencies who have legacy systems that were really never built to be integrated with in the first place. And as agencies move systems of record now into the cloud, this further complicates things because now agencies have to span a hybrid environment, which introduces more considerations and of course, security constraints. And then finally, a digitally connected government agency does not necessarily mean a data sharing one. So I think agencies really have to strive to improve not only how they're sharing data within their organizations, but also outside of it. So that's my half of the talk here. I will flip it back over to you, Mike.
Thanks, Darren. Before we get started, there's still time to submit questions. We have quite a few here. Terry, I'm going to throw the first one out to you. What did the IRS do to develop programming to meet the needs of the IRS?
Well, with the legacy systems starting way back in the 1970s, Assembly language was the preferred solution, and in fact, still is the dominant language for those tax processing systems I mentioned, the 36 of them. But there's also COBOL, and in today's age is a standardization actually on Java, in a particular framework for Java called Springbok. Recognizing that people who come out of college are not learning the legacy languages, but yet still having a need, we actually teach assembly language courses at the IRS for folk as we go about the task of rewriting. So the opportunity is come in and use your new found skill, such as Java, to do the rewrite. But meanwhile, we have to sustain the old programming language like assembly language or COBOL. Now, as Darren mentioned, these are actually very robust programming languages. There's nothing wrong with them per se. It's just there aren't enough people who have deep knowledge of those particular languages. So in our solution is migrate to Java, but in the meantime, provide programming classes to people who are already talented in other languages and let them do both, let both worlds survive. Meanwhile, I should say the infrastructure that you run on is very much state of the art. While a lot of it is mainframe, so to speak, it's the high-end mainframes, the Z90s and other technologies. So it really is a robust platform. We just need the right skilled programmers. And it's also why I said people are a key aspect of this. Those folk who maintain the legacy apps have to see an attraction as to why they should use a data model, why they should now use APIs. It allows them, and I believe, a great career path to be using those most technology advanced tools like from Software AG while they are sustaining the basic business processes of the enterprise.
Oh, thanks, Terry. Darren, and Terry just mentioned it, COBOL, and I believe you mentioned it in your presentation as well. How does web methods connect to mainframes?
Yeah, COBOL and mainframes, on mainframes in particular, can be a challenge to integrate with for some, solutions. However, Software AG actually started back in the late 60s with mainframe databases and early programming languages. So not only is there a rich history there, over the decades, Software AG has developed a very robust set of mainframe adapters. And one of the real advantages to Software AG is that the people, in the organization have been working with these technologies for all of these decades. So the amount of know-how for some of these older programming languages and just how those things work, even running on the newer Z90s, having that knowledge is really nice. So if I'm working on a project, I'm only a phone call away from picking up the phone and reaching somebody who has that. And I think it goes back to Terry's focus on people, right? The technology is just an enabler. When you combine that enabler with the people's, where you can really advance very, very quickly. So being able to access COBOL, like COBOL is the logic, right? The logic that has been written for, let's say, tax processing or whatever that business problem was. And so having the ability to access that is really nice, because we can leverage that, right? It's still good, the logic still works, but let's wrap that and execute it in a way that potentially we could expose as an API, and then expose it to newer systems or expose it to Java systems in the case of the IRS. Or we can access it at the database level, and I'll use database as a general term. Terry mentioned the sequential files earlier. There's lots of what I would characterize as databases on the mainframe, but they're not typical relational databases. So accessing them, you need to get to them in a special way. So we have special adapters to enable us to access that at the data level as well. And then when all else fails, we have another option, which is we can record actual what we call green screen interactions, someone working with a mainframe on a terminal, and kind of record them almost like a macro, and then we can replay that macro at will and then wrap that as an API. So we have a lot of different options in terms of being able to leverage existing investments while that modernization or transformation to a newer technology is occurring. So it gives the it gives agencies like IRS a lot of freedom and flexibility to evolve their ecosystem.
Yeah, Terry, a follow-up question here is, and maybe I'll just add some color commentary. As someone that's been doing live events for 35 years and have listened to countless presentations on how this new technology is going to solve whatever problem was existing, and many have. That wasn't necessarily a negative comment. It's just it never works unless you have the people on board. And so can you go into a little bit more detail on that? On, if you have someone, especially a recent graduate, like someone in my family, they learn Python, and there's Java out there, and, they join the IRS, and then, you have your, extensive modernization plan that's been going on for years, but then you're telling someone recently graduated that, hey, it's also beneficial to learn this older programming language. So can you just elaborate a little bit on, when you were there and in charge, what you did with people and the impact that people had on whatever modernization program you did?
Sure. I'd like to actually start with those who had been there a while, as opposed to the newcomers. Those folk who sustain and maintain these legacy apps in the IRS, and there's 700 of them, have long-standing vested interest in the quote keeping it as it is, sustaining and maintaining it, whatever the programming language is, and thus getting them, enrolling them in the possibility of getting the data access by other applications became a opportunity to show them that they could literally be world class by allowing the changes to occur and their being part of it, such as being part of the team that wrote the data model and sustained it, or being part of the team that stood up the database, the relational database of the tax processing returns, all those VSAM files I mentioned. This then became a very nice career path for someone who had the skills and was a master of the craft for assembly language or COBOL to actually start using the new. And then there are the folk who write all the extracts that I mentioned, that historically, this is how data gets shared. Write an extract to pull from this system and make it available to that. Well, with the use of the tools that Darren mentioned, this becomes a very enticing thing for those folk to learn something new, which makes them marketable, not just at the IRS,
right,
but elsewhere in government or even outside if they like. The key is it's an attractor for talent. They are not stuck just doing the same old thing. Now, for those who just want to stay, that's great. We can handle that. But now we want to bring on new people fresh out of school and help out the current team. Yes, they'll have opportunities to use their skills that they learn, whether it's Python or Java. Java is our standard programming language for applications. But also, if they have to sustain an event, it's healthy to learn that other programming language as they go about implementing the API techniques that Darren described, and make themselves a far more versatile employee, far more valuable to the IRS if you have multi skills. So that's what we did. We focused also on, I think I mentioned, providing training in assembly language, actually teaching a programming course, because it's rarely offered in most schools, including the trade schools and such. Same thing for COBOL and other languages. So over time, as people retire, the newcomers in will have had the opportunity to participate in technology rollouts that ease the path and migration of getting all the business processes rewritten in current state-of-the-art languages. And in the meantime, they can take advantage of world-class tools like web methods. What Darren showed, we began this some years ago, was just tip of the iceberg for the IRS. We didn't even realize, oh my God, we're creating an integration hub. But that's what we ended up doing. And still with the vastness of those tools that Darren described, the many ways we're still very much learning how to take advantage all that stuff that's available.
Excellent. Thank you, Terry. Darren, this will be the last question. We're coming up on our time here. There was a mention of integrating with banks. Can you elaborate on how WebMethods accomplishes integration with banks?
Yeah, sure. So there's a lot of options in terms when you talk about integrating. For the most part, we focused our efforts on creating, these adapters that are pluggable into the WebMethods platform. And some of those adapters focus on specific technical connections, like for example databases, or they may focus on mainframes. But in the case of banks, what several of the major institutions throughout that industry came together, and they defined standards for how they were going to exchange data. And so we work with not just financial systems, but other industries. But some of the standards are things like SWIFT or ACH, for example, for moving funds electronically. So there's kind of a bucket of our adapters that really focus on e-standards for specific industries. And with the banking example, we leveraged those adapters to be able to exchange data bidirectionally using those financial standards.
Well, thank you, Darren and Terry, for joining us today. For those of you that submitted a question we did not have a chance to get to today, one of us will be following up with you as soon as we have a chance. I'd also like to thank the audience out there today. We very much appreciate your continued support. So on behalf of the Digital Government Institute team, again, thank you, Terry and Darren. This concludes today's webinar. Have a great day, everybody.
Thank you.
Thank you.